All right, all right. You got a little homework assignment tonight. Get you some versatility with the Vernier video analysis program. So you will open up an assignment. Looks something like this. Lab 3.1, analyze this video 1. There'll be some links down here. There's a video I sent you with the help of a student. It's called Ball Drop 11/22/21. You will click that video. Here's what it looks like. Whenever you're ready. That's some real video excitement right there. Anyway, you're going to download it. And wherever it downloads, good. For mine, I'll show in folder. I'll see where I have it. Okay, that's where I have it. Fine, good to go. Then I'll come back over here. I'll open up Vernier Video Analysis. Now, if you've already done this on your computer, then you already have the license. If not, come over here, highlight, not the space, this full license here, do a little copy paste, and then actually just copy. Then open the Vernier Video Analysis. There it is. If it asks you for the license, that's where you paste that key that we had right here. I think it's an L or maybe it's a capital I don't know. That's why you just copy and paste it. Anyway, here we need to choose a file or import video. Doesn't matter. If one doesn't work, try the other, but it shouldn't matter. So I'm going to choose a file. I'm going to go to my downloads folder. And I'm going to pick that ball drop, 11/22/21. There it is. Open. Boom. So if you had problems getting up to this point, hit that pause, go back, do it again. All right. So here's the full video. Let's play it. I'm going to shrink down the graphical analysis for the moment. Okay, cool. So I'm play it again. I'm going to pause it right around the time he lets go. Fine. If I click on the cursor up here, then I can use the arrow keys on my computer, the left and right arrow keys, to move back and forth to where I want. Now, we were careful to do a couple of things well with this video. Number one, we taped the tape measure, or the meter stick rather, on the wall, and we tried to make it vertical. We actually used the level app on the phone to make it vertical. Taped it on the top, and you can't see below the screen, but also taped it on the bottom so it stayed vertical. The dropper, if you notice up here, you can tell by way of his hands. Let's get up close there. He's holding the ball by the fuzz, not gripping the ball on the sides, because on the sides, when you let go, you tend to push it with your fingers. He's actually holding it just by the hair. He actually has his other hand bracing this hand against the wall so that there's no movement. We actually did a first version of this, and the hand pushed the ball down a little bit as it let go. Here, by bracing his own wrist, he's really focusing on just, you can watch here, just releasing with his fingers and not giving the ball any sort of push. You see that little fuzzy had hold up. That's pretty good. This actually is easy to follow. He did a pretty good job. Also, by leaning on the wall, the ball is right next to the ruler, which minimizes that effect that we sketched in class. It's actually called the parallax effect. Basically, the farther the ball is from the ruler, the bigger the issue is with the angle of the camera view. Okay, so that's kind of the setup. Now, here we are again. What we need to do is a couple of things. First off, we want to get to the first frame of our video. So here the ball's already falling. It looks like at this point he's let go. If we zoom in, by the way, the zoom in is a pretty cool thing. Notice I have not clicked anything on the left side yet, nor have I clicked anything in the video. Wherever your bullseye or your cursor is located, if you zoom in using the scroll bar on a mouse or just double finger, I believe, on your little trackpad on your computer, if you scroll in, wherever this cursor is aimed, that's where you'll zoom in. So if I aim in the middle, it'll zoom in the middle, zoom out. If I aim by the ball, zoom in on the ball, zoom out. By the hand, zoom in on the hand, zoom out. So it's a pretty cool thing. So you can get a better view of what you're looking at, and then zoom out. All right, good. So if we're going to zoom in on the ball here, back up a little in his hand, let's go back to the cursor and use the arrows to see when the start of this is. See, to me, that's already moving. So this would be like frame 0, frame 1, 2. Looks like a little skip in the frame. There it goes. 0, frame 1, 2, 3, 4, 5, 6, 7. And then you can't see it anymore. Scroll out, and you can zoom back in maybe in the middle and follow it as it falls. All right, so let's back up, because what we really want is, where is that frame 0? I'm going to zoom in up here again. Frame 0, probably that one. Then it's let go, so it already started falling. So that's 0. It hasn't fallen yet. Now it's already on its way. So let's say this is my 0. So what do we do here? First off, that's where we want to set our origin. How do we do that? Click over here. It says System. Okay? Now, System has this little spacer, which we're going to use. We'll worry about that in a moment. And it also has a button called Origin. So I'm going to click on Origin. Now, notice I can't see it. That's because it's out of the screen. Let me back up. I'm going to grab the center of this and move our origin. Now, I'm going to let go of the origin. I'm going to come over here and zoom in again so I could really try to aim this. We're going to leave it in Cartesian. I am going to follow the bottom of the ball. You can follow the middle of the ball, the top of the ball, whatever. But I think the bottom, at least for me, is a good idea. So I'm going to set my origin right at the bottom of the ball, just like that. Right there. That's I guess the best I can do. You might disagree with me slightly, but that's where I put it. Now I can zoom out a little bit. Remember, that came from System Origin. I just moved it so it's where I'm going to start my points. We also need a scale, so I'm going to click Scale. All right, the origin's already set. Don't worry. There it is. Let's go do Scale. I'm going to set mine to points I can read. So I see that this is like the 1 meter mark. I'm going to zoom out, move this over here. I can see right or 1 centimeter mark. It looks like, yeah, there's 5 right here. 4, 3, 2. Oh, so it's not 1. It's a 5, 4, 3. That's a 2. So maybe I'll line this up right here at the 2. Pretty good. I'll zoom out, try to keep this thing straight, and maybe I'll go to that's the 30. Right? Yeah. And the 30, the way these tick marks go, they go in the middle of the number. So where the 3 and the 0 meet, right around there is going to be about the 30. So I went from the 2 to the 30, which means 2 to 30 is 28 centimeters, and 28 centimeters is 0.28 meters. So how did I put 0.28? Good. Now I'm set. I've got my origin. I've got my scale. I'm good to go. You can use a different scale. Maybe you see from 2 to 40, whatever it is. I don't care. Just do a careful job with it. Notice that my camera is lined up with the top of the ruler. That's why that appears more at eye level. And the bottom is a little farther away. Maybe try to use your scale more in the top part of the ruler. All right, now it's time to add points. I'm going to come over here. I'm going to click Add. Cool. Now, because this is tight, this is kind of small, we're going to zoom in over here. All right, we called this our frame 0. So I'm going to zoom in, and I'm going to try to put a dot right at the bottom of the ball. That's going to be my frame 0. Boom. Now, if you notice, it's frame 0. Frame 1 is, let me back up again. That was frame 1 is like right there next to it. Okay, then frame 2. Now, notice the ball takes on like, a little bit of a halo here. It's hard to tell where it is. I'm going to try to follow the leading edge of the blur. Now, I'm not 100% that's the best choice, but that's what I'm going to do. The leading edge of the blur. If somebody disagrees, I'd be curious to see what you get. The leading edge of the blur looks right around maybe there. Then there. Then there. Should we back up one? If you're ever not sure, come over here, click the cursor, and just back up one. Left arrow. If you feel like you don't like that one, you can come over here to the left, click Edit, grab it. You can either move it or trash it. Gone. So now I'll go back over here to Add. What do I think it is? I could have just moved it to maybe there. Here, maybe here. And here. Now notice it's off the screen. So zoom out and then aim where you want to zoom and zoom back in. So maybe here. Here. Let me zoom out. Zoom back in. Here. That's probably good. That's the best we're getting out of this. There it is. Now, if you have trails over here turned off, you will not see them. Then, if you click the cursor and go backward, they'll show up. But if you click trails, you will see all of them up to wherever you are in the video. So go back to the cursor. You can go backward, forward. All right, that's what we got. Cool. Now it's time for some analysis. So let's pull this graph over here so we can look at it. There's a few things written. Now this is a vertical problem. You notice it fell down. The X direction, which is written in red, the horizontal direction, that doesn't matter for us. So we're going to click this change Y-axis, shut off the X, and now we have only the Y. Cool. There we go. Now I pressed right here, zoom to all data. See that little button there, zoom to all. That'll get everything in there that we're looking at. It looks like we're starting right around on 0, which is what we wanted. The origin was right at our beginning. And then it is increasing displacement. This is meters. This is displacement in the negative direction. Well, that's what we see here. That makes sense. Also, we see that it's curved. That curved means a changing slope, which means a changing velocity, which makes sense. As you see, the spacing is increasing here. So the velocity is changing. Now let's do an analysis. So we're going to click Graph Tools, and we're going to click Apply Curve Fit. Now, linear clearly isn't a good choice. When you have the end points on one side of the line and the belly or the middle on the other, it's probably a curve. The curves we use in here, quadratic is going to be our friend. Let's click that. Okay? Once you hit quadratic, you have a nice smooth parabola. Hit apply, and boom, here's our equation. Now, this one is my equation from what I picked. It depends on where I put the dots. It depends on the scale I used, what was 0.28 meters, whatever it was. So you will make slightly different choices and you will get a slightly different answer, which is part of what I want. I am not a perfect experimenter. None of us are. But by combining all of ours, perhaps that'll help minimize some of the random measurement errors and get us to a better answer. All right. So what you're going to do here is you're actually going to record this information. This information here, y equals ax squared plus bx plus c, and you're going to record the a, the b, and the c. You actually can write it substituted just like that. Now in the assignment, what did I say here? Open the shared Google Sheet and enter a new line for your information. Well, let's do that. I actually have not put the Google Sheet on here, but let's do it right now. Not a big deal. So we're going to have a couple of spots here. This will be the D verse T graph. And then we'll have another one for the V verse T graph. So we'll have student name. So we'll do, actually, we'll just do last name, first name. So we'll space these out too. I'll make it nice and spaced out. We have a whole bunch of people doing this. So whatever, I'll fill out the file for you, but I'm going to space these out nice. When you open it up, it'll look a little different. Maybe not quite that much. Whatever it is, I'll put in here. Verbit, Mr. Like I'll even be nice and vertically orient this. There we go. And so what you're going to do here is for your D versus T graph, what I want is your A, your B, and your C. Okay? Your A, your B, and your C. And for mine, good, we got the vertical line. For mine, A is negative 5.063. Negative 5.063. B is 0.0. I wonder if we can copy and paste. Let's try it. Yeah, highlight, copy, paste, boom. And then C is 0.001369. Copy, paste. By the way, I can center this too. If you don't like the formatting here from copy and pasting, watch this cool thing you can do. This is centered, and it's got a certain font of a certain size. It's also vertically aligned center. These are different. So there's the little paint roller here. Go on a cell where you like the format, hit the paint roller, and then highlight all the others. Boom! They automatically assume the same format as that cell, which is a pretty cool thing. Save that till the end. So that's the D versus T graph. We are also going to do the V versus T graph. Please don't mess with other students' entries. This is going to be shared for everybody to fill in. Don't go in here sloppy, deleting other people's stuff. So for this one, it's going to be a little different. All right, let me show you what to do. The V versus T graph. There's our D versus T graph. Done. We can X out of the quadratic. Now, go to your y-axis, and we are going to change it. We don't want the y anymore, the meters, which is actually the displacement. We're going to shut that off. Now we want the y velocity. So turn that on. One more time, let me show you what we just did. It looked like this. It actually had a graph on there. X out of the graph stats. Come over to the y-axis. Shut off the y position, that's the displacement. Turn on the y velocity, that's obviously the velocity, and you have a graph. Now we're going to again apply a curve fit. This one is going to be linear. Leave it as linear. I know it looks a little sloppy. Press apply, and we have some information over here. This time it's a y equals mx plus b. It's not a y equals ax squared plus bx plus c. That was quadratic, this one's linear. Here in the linear, we have m and we have b. So copy m, which of course is your slope. Hopefully you remember that. I'll come over here. This is going to be m. This is going to be b. M. And this is my b, negative. There it is. Copy. Paste. Good. And I like the format of the mister, so I'm going to copy it with the roller and highlight these two. Boom. There it go. All right. So that's what you're doing. Now, once this is in here, you're good to go. We're going to look at this tomorrow. We're going to analyze this a little bit. You don't have to do anything else over here. Now, let me show you something. Let's say there are a bunch of people entered here already, and now it's your turn to go enter it. And by accident, you like highlight this one, and you make a mistake, and you hit delete, and everything's gone, and you're hitting undo, undo. You don't know what. Listen, everything can be undone. It's very easy. Just click into another box so you're outside of the mess you made. And you either can come over here and click the undo button or press Control Z. Or if you're on an Apple Mac, press Apple Z. Undo, the stuff goes back. Very easy. I'm even going to color shade these so you see like gray, white, so you leave the other people's work alone. So very simple process. When you are done, nothing else to do in that Google Sheet. I'm just going to look at your stuff. You come over here, go to the File menu, that little paper up there in the top left, Save As, and it automatically downloads it to your downloads folder, I believe. But you can always show in folder, find where it is. Mine says Untitled. I'm going to rename it Burbit Ball Drop 11/21, 11/22/21. Actually, I'm going to put in there sample. And then when you close out of this, you can reopen it the next day. This is how to analyze. You are going to drop your own. You're going to set up your own scenario and do this well in the next class. All right, then.